Hey everyone, welcome. Welcome to the workshop. Let's get some GMs going in the chat and let us know where you're from and what time it is there. We're going to give it just a couple minutes for a few more people to come in. Ooh, Belgium and Serbia, nice. India, nice. London. JP, is that Japan? 9 a.m. New Jersey, welcome. Munich, awesome. California, ooh, early one for you. Awesome to see so many people from different countries all over the world. We're going to give it one more minute and then we're going to get started. India, Madrid, nice one. Russia, awesome. Hey, Melody. Okay, I think we are pretty much ready to go. Pakistan, nice one. All right, let's get started. I'm going to share my screen. Hopefully everyone can see this. Let's try this one. Awesome. Can everyone see that okay? GM from Turkey, nice. Okay, so let's get started. So welcome everyone to another Fall 2022 Chainlink Hackathon workshop. Today, whether it's this evening, this morning, this afternoon, we're going to introduce you to what Chainlink is and the trust minimize services that Chainlink offers. So for those who have never used Chainlink before, never heard of Chainlink, you'll get a great introduction and understanding of what Chainlink is and what some of these Web3 services are and how they can help you in your smart contracts. And if you've already heard of Chainlink and you already know and you're just getting a refresher, it's kind of good to just kind of refresh your memory on what some of these Web3 services are and how they can kind of help you boost your smart contracts and really take them to the next level. So let's get started. How many people here are gamers? Let us know in the chat if you like playing games, desktop, console, whatever. Any gamers here? Yes, okay, we got a few here. Awesome. Yeah, me too. So with a lot of games, whether it's a first-person shooter, RPG, or whatever, when you start the game, you've got a character or characters, and the character's weapons or equipment or stats is pretty basic, right? It's enough to get you started, but as you progress through the game, you kind of need to level up and get more weapons, more equipment, better play stats, so you can successfully navigate the later stages of the game, right? Because the game usually gets harder, right? So I feel like it's kind of similar for Web3 development. When you start by building these basic smart contracts. You start by building these things on the blockchain. Maybe you write a dApp, maybe you mint an NFT. Well, this is great. You can do a lot just on the blockchain, but you kind of get to a stage where when you're building smart contracts and decentralized applications, you eventually reach a point where there's things you want to do that the blockchain cannot do on its own, right? Because blockchains are limited. So this is where you need something else. This is where you need something more, right? This is where you need a service. So just like when they built Uber, they didn't try and write their own messaging systems and GPS system and payment systems, right? They basically use services. So something that can help you level up your DApp or NFT or whatever you're building so that it has all the capabilities of a traditional Web2 app, but it does it even better because it's got these unique security and reliability properties that blockchain has. So that's kind of what I'm trying to say here, is that Chainlink provides these services to kind of really level up your smart contract development and allow you to build more feature-rich decentralized applications. So in the next 90 minutes or so, I'm going to share with you how Chainlink can really help you level up your Web3 dApps and NFTs and all those types of things, and really take them to the next level where they become feature-rich applications that have a lot more of the capabilities that traditional Web2 applications have. And yes, great comment. I relate to this a lot. Things become really hard. Hopefully we can help a little bit. So my name is Harry Papakarisiou. For those that don't know, I manage the developer advocates at Chainlink Labs, and I'm thrilled to be here today talking to you guys and girls about Chainlink. If you want to connect with me, my Twitter is pappas9999. I'd love to interact with everyone on Twitter. I'll share it here. And I've got a link tree there where you can find some more socials if you just search for Pappas99. So let's start by talking about blockchains. So blockchains are amazing and they're awesome, and they have these unique security, reliability properties that other systems don't have. But one thing that they also are, because they have these properties, is that they're deterministic, right? So what that means is each node in the blockchain has to process a smart contract or a transaction exactly the same as every other node, right? So when you're doing something like maths, it's pretty easy, because if every node processes 1 + 1, they're all going to get 2, right? It's maths. But what happens if there's a smart contract that says, tell me what the weather is in Mumbai right now, or tell me what the weather is in New York right now? You know, what happens if some of the nodes get different results, right? All of a sudden, one node gets, 70 degrees, one gets 71 degrees, one gets 72. Then how does the blockchain continue when the nodes are processing instructions and getting different results back, right? So this is what we mean by deterministic. There are these blockchains of this closed-off system that are purposely built like that so they can all stay perfectly in sync when they process transactions and instructions. So it's because of this determinism, that blockchains can't really reach out to the outside world and do things such as API calls and things like that, because if they do that, they can lose their determinism. And if they lose their determinism, then your blockchain breaks or stops, right? So this is what we call the smart contract connectivity problem. Thanks for the kind words, Mohammed. Thank you. So let's move on. Another word for this, or another term, I guess, is also the oracle problem. So not being able to connect a smart contract to external data or events, right? So what is the solution to this problem? Because like I said earlier, doing things just on the blockchain is awesome, but you're going to get to a stage eventually where you're going to want to do things off-chain. You're going to want to reach out to APIs. You're going to want to do off-chain computation. You're going to want to do implement randomness in your game or something like that, right? So the solution to the smart contract connectivity problem is you need what's called an oracle. So an oracle is a system that sits between a blockchain and the outside world, and acts as kind of that connectivity point between a smart contract running on a blockchain and any system in the off-chain world. Yes, this video will be made available on this exact YouTube link as soon as it ends. So it doesn't need to be uploaded anywhere. You can just rewatch it on YouTube. So we've talked about what an oracle is now. So, but the thing is, if you just use a single oracle to connect a smart contract to the outside world, it actually creates a single point of failure, because you've got this highly secure, highly reliable blockchain here with hundreds of nodes or thousands of nodes. Then you've got a single oracle here acting as a connectivity to the outside world. And if something happens to that oracle, or if it's tampered with or gamed or exploited, then you can actually compromise the whole security of your system. So this is where we say using a centralized oracle is a point of failure. So the answer or the solution to this is you should use a decentralized oracle network instead of a single oracle to connect your smart contracts to the external world, right? So what we do is we decentralize the data delivery layer, which is the oracle layer, and by doing so, we kind of mimic the trust minimization and kind of security properties that the blockchain has, and we apply it to this kind of data delivery layer as well. And by doing that, the overall security of the system and reliability remains high because the layer in which the oracle network on is just as secure, just as reliable, just as tamper-proof as the blockchain. So this is what Chainlink is. It's a decentralized oracle network. You can comprise, you can make whatever oracle networks you want for price data, API connectivity, and more. And we're going to go through this in the coming minutes. So here's an example of a Chainlink oracle network reaching consensus on price data for a smart contract. So as you can see, there's a whole number of oracle nodes there, each of them getting data from different data sources. There's a report that's generated with a number of prices, and then that report is sent on-chain, and then those prices in the report are then aggregated again into a single response, or a single price, sorry. So there's an example of, that's Chainlink data feeds there actually. So when you combine an on-chain smart contract with an oracle network or this kind of off-chain computation and connectivity, you actually get what's called a hybrid smart contract. So a smart contract is just, people think of it as just code running on a blockchain. But when you have code and you combine it with these oracle networks off-chain, it's actually called a hybrid smart contract when you combine the two. Cool. So that's just an overview of, what is the Oracle problem? What is an Oracle? What is Chainlink? Now let's go through some of the Web3 services that Chainlink offers you as a smart contract developer for your hackathon project. I'll just answer one of the questions in the chat. What exactly is an Oracle network? Sorry, not a native English speaker. So an Oracle network is a collection of oracles that all work together. Let me go back a couple of slides. That all work together and talk to each other and reach consensus on whether it's data or an API call, something like that. And then they deliver that result on chain to the smart contract. Cool. So let's move on to Chainlink data feeds. So if you're building something like a DeFi protocol, there's a decent chance that you're going to need price data, right? You're going to need to know the price of Ethereum, the price of Bitcoin, or something like that. So price feeds enable you to be able to consume this type of data and use it on-chain on your DeFi application, right? So, and it does this by providing high-quality data in an extremely secure and reliable way. And the way it works is you have an Oracle network, like I explained earlier. It might be 16, it might be 32 oracles all talking to each other. And what they do is they then go and reach out and they get price data for a particular asset. It might be the price of Ethereum, the price of Bitcoin, etc. And they get data from multiple sources. They get it from multiple aggregators, exchanges, etc. The data sources end up being in the hundreds, right? And then each of these Oracle nodes in the Oracle network aggregate the data that they get, and they get a price. So each Oracle has their own price. And then from that, a report is generated containing each individual Oracle's price. And then that report is sent on-chain. And then the report that's sent on-chain is then aggregated again into a final price. And then that price that's on the smart contract, that price that's submitted on-chain, and then that final response, that is the price of that pair at that time period across the whole landscape. So if it's like the price of Ethereum and it's aggregated and sent on chain and it's like $1,200, then Chainlink data feeds is saying right now the price of Ethereum across the whole markets across everywhere is $1,200. So if you want to take a look at our data feeds, you should head to data.chain.link. and you can kind of go through and see all of the data feeds there. Let's just take a quick look. Oh, excuse me. I will go edit.chain.link, bigger. As you can see, the data feeds are live on multiple different networks. We'll take a look at the ETHUSD one here. So as you can see, we have is that 32 oracles, I think, maybe. It's got the latest answer here, and there's some historical data here. So you can see this is the current price of Ethereum on Ethereum mainnet. And there are these things here called deviation threshold and heartbeat. So the way that the price feeds work is if the price alternates by more than what the deviation threshold is, then an update is triggered, right, for the price feed. So the price feeds don't constantly update the current price because that wouldn't be very efficient. So there's some smarts in them to say, if the price has changed by more than 0.5% in this case since the last update, let's push an update. Or if the price hasn't changed by that much, but if this amount of time expires, then we push an update anyway. So that's what the heartbeat is. It says if there hasn't been an update in X amount of time, in this case, it's probably the heartbeat's probably an hour, then we want to trigger an update anyway, as kind of like a fallback or last point of like updating data. So at least you're going to have data updated every hour for this price feed by the looks of it. It's a great question in the chat here. Can you share some examples of popular non-financial data feeds? You mentioned weather, any others that are being used a lot? Yeah, we're seeing some emerging use cases around sports data. So it's data based on sports results and things like that. And we're also seeing some emerging use cases of real estate data too. And if you go to our blog at blog.chain.link and you search for sports data and you search for real estate, you'll see some really cool use cases and examples there. So just to reiterate, the deviation threshold defines when the price feed should update if the price changes by more than that amount. So right now, the price of Ethereum is $1,287.15. The Oracle, when the Oracle network gets a new price, a new aggregated price, it will then compare that to this. And if the price is different by more than 0.5%, then it will say, okay, we need to update the on-chain price now. Great question. Okay, let's move on. So Chainlink price feeds use what's called full market coverage. So we don't take a look at just specific high volume exchanges and things like that. We try and take a look at the whole market to get a whole market aggregated price to say this is the price of this asset across the whole market, right? So we use a mix of premium data providers and exchanges, and we use what's called a volume-based average method of aggregating data. So the nodes take a look at the volume and work out averages based on that. So like I said earlier, the biggest and most obvious use case for Chainlink data feeds is DeFi. So our price feeds are used by probably over 50% of DeFi today, I'd say. And here's some notable kind of DeFi protocols that are listed there. And another thing to take into account is security, right? So one important way that Chainlink data feeds help DeFi is with security. So with DeFi protocols, there's a bunch of potential attack vectors, and oracles and price data is one of them, right? And if you're using Chainlink data feeds, you're basically using the most secure, the longest running, and the most reliable data feeds on the planet, right? So it means your chances of getting your protocol exploited with a price oracle attack or a flash loan attack or something like that is extremely low. So yeah, Chainlink data feeds plus 100 armor for your DeFi protocol. I see another question in the chat. Is it possible to see what the data is reflecting on different nodes or is only the final value accessible? So if we go back to data.chain.link, you can see each individual node has a price underneath it. So you can see what that node reported as part of the latest update. But then this answer here is that final aggregated answer. So you can kind of see both here, each individual node price and the final aggregated price here. Okay, let's go through a demo. I'll answer any other questions on data feeds after the demo. So if you head to docs.chain.link, this is the place to go for using Chainlink in your smart contract applications. We're going to go to EVM chains today, and we're going to use the Ethereum Go Early testnet, and we're going to consume a data feed on there. So there is a section here called data feeds, and we are going to go to introduction to data feeds. No, we're going to go to price feeds, using price feeds. And as you can see here, there is an example smart contract here. We're going to open this in Remix, the Remix IDE, and I'm going to zoom in because that's too small. Hopefully everyone can see that okay. Remix is an online IDE for creating smart contract applications, and I'm going to be using MetaMask to sign transactions. It's an online wallet. One thing to note is you're going to need some Go Early ETH, and we're also going to eventually need some link for some of the other demos. So if you go to faucet.chain.link, that's how you can get some testnet, ETH, and link. So if you go there, if your MetaMask is connected to the Go Early testnet, you can then have your wallet address put in, and you tick to say, yes, you want some testnet link, and yes, you want some testnet ETH. And unfortunately, you need to verify that you're a human with a Twitter account, because we found that bots have been taking a lot of the testnet ETH. So that's why that's there. Hey, Crystal, how's it going? Please click each image containing a teacup with a similar porcelain design pattern. Does anyone ever fill these out and sometimes think that they're like not human because they get it wrong? Or is it just me? I feel like they're getting harder and harder. So yeah, once you fill that out, you send request. And in my case, I already did a request in the last hour, so it's failing. But in your case, it should successfully get processed, and you should get some testnet, Go Early ETH, and link as well. If you don't see link in your MetaMask here, if you go to the Chainlink docs and go to the bottom here in acquire testnet link, acquire testnet link. No, in link token contracts, if you go to Ethereum Go Early testnet, there's an add to wallet button here, which will add the link token to your wallet. So let's go back to the price feeds now. So this is our smart contract for price feeds. As you can see, we're importing a Chainlink library here. It's a very simple smart contract. We're creating this price feed variable here based on this library. And all we're doing is, in the constructor, is we're setting the value to this address here, right? So we're saying create aggregator v3 interface, and we're passing in this address. So this address is the price feed that we want to consume. And the place to get this is if you go to contract addresses here, and if you go to Ethereum, we're going to scroll down to the Go Early testnet, and you can see here are some data feeds here that you can use. So I think in this case, we're using the ETH USD price here. And all we're doing once we set that in the constructor is we have a function called getLatestPrice, and it just calls this price feed dot latest round data. And this just returns some information from the price feed. And in this case, we're just interested in the price, and it just returns the price. So we're going to compile that one in the compile tab here. And sorry if I'm going a bit fast for people, but you can follow along after in the video as well and watch it at a slower pace. Then in the deploy and run transactions tab, we're going to change this to our MetaMask here. We're going to make sure that we have the correct smart contract here, the price consumer one, and we're going to deploy the smart contract to the Go Early testnet. We'll give it a few seconds to deploy. Cool. So once that's done, you'll see in the deployed contract section, you'll see a little kind of smart contract's been deployed there. And you can see this little blue button called Get Latest Price. And I know it's a little bit small. We'll try and make it bigger for everyone. Let me just hide my face for a minute. There we go. So if you have a look at the result here, you can see the price of Ethereum is here. So it's $1,285.61. The numbers are padded out because Solidity is not good with decimals, or it can't do decimals. So there's some padding going on here. And yes, there's some great comments in the chat. Be careful when using MetaMask wallets. When you're playing around with development like this, it's recommended to not use the same wallet addresses as any mainnet funds that you have. It's always good to create new wallet addresses that you don't have any funds on mainnet and just use that for development purposes. Cool. So that's data feed. As you can see, with just a few lines of code, you can choose a data feed and get the latest price data for that feed using Chainlink data feeds. With literally just a few lines of code. Awesome. Let's have a look at the chat here. Do those providers get paid for providing data feeds? Yes, great question. So each individual Oracle here, they get rewarded in link tokens for providing that price data and to offset the ETH that they need to pay for gas fees to submit that price data as well. Great question. If you have any other questions, feel free to ask them in the chat. What's MetaMask? MetaMask is a Web3 wallet, so you need a wallet to sign transactions and submit transactions to the blockchain. So MetaMask is the most popular Web3 wallet, I'd say, that's out there for Ethereum based blockchains. Will there be an upcoming session on how to build a new data feed? Maybe in the near future. We don't support people creating their own custom data feeds just yet. However, there's nothing stopping you from trying to create your own using our API call functionality, which we'll get to later on in this session. Last question here. How accurate are the data feeds? Are they real-time or updated in an interval? So as I explained earlier, the data feeds have what's called a deviation threshold and a heartbeat. So the heartbeat defines how often it should update if the deviation threshold isn't met. And the deviation threshold defines the condition that they should update based on a price difference. So in this case, if the price difference is off by more than 0.5% from the last stored price, it should update. Otherwise, if not, it should update in 52 minutes. Okay, let's move on to randomness. Does anyone here know what VRF stands for? We'll find out in a minute. So randomness is actually a fairly important feature when building applications, especially if you want to build things such as games. So the thing is, until recently, getting random numbers on chain has kind of been an issue because the previous conventional way to get random number is you generally had to rely on an on-chain thing such as an on-chain hash, or you had to use a centralized API that can kind of be hacked and stuff like that. So imagine a lottery or gaming contract that uses on-chain values such as block difficulty and stuff to determine the winner, right? So in this case, it can easily be influenced. So this is where Chainlink VRF comes in. Chainlink VRF provides a fair and verifiable way of getting true randomness on chain. So just at a very high level, what it offers is the ability for a smart contract to get a random number or any number of random numbers. And using those random numbers, you can then have a source of randomness for your game, for your NFT drop, for whatever you're trying to do, right? And the way that which this works is you basically create what's called a subscription. So it's basically exactly as you think it is. It's a subscription that you then fund with link tokens, and then you then can use when you build smart contracts, right? So then you build a smart contract that needs randomness, and then you say, all right, I want to link this smart contract to my subscription that's funded with link tokens. And then in your smart contract, you can then request randomness as part of your smart contract code. And then what that will do is it will send a request. The request will get sent to a Chainlink Oracle. The Chainlink Oracle will do the VRF and get your random number and then send it back. And it actually also generates a proof to prove that the random number was actually random, right? And the way that it does this is when the random number request is generated, there's what's called a seed. I think it's called a seed that's stored in the as part of the request. And the seed is comprised of the block hash and a few other things. And it's basically an input source for a random number generator. And then when the random number comes back, there's a bunch of magic maths and cryptography that happens that then verifies that the actual random number came as a result of that initial seed. It actually proves that it came from that seed, and it's not just some number that an oracle or a miner or someone put in there on purpose because they're trying to exploit the contract. So that's what we mean by verifiable random number. It's not just random. We prove that it's random. Question in the chat, what are smart contracts? Great question. So for a beginner, smart contracts are self-executing programs, or basically programs that are put onto a blockchain such as Ethereum and then executed by all of the nodes on the blockchain. Are Chainlink services for new developers free? Yes. If you're playing around on a testnet, every service you can use is free because you can get testnet link for free to fund them. On mainnet, if you deploy on mainnet, it's not free unless you're using price feeds. I think price feeds are for individual developers are free on mainnet. What does it mean to have a random number of random numbers? Does that mean you set a value and then you can choose randomly from the set? I'm not sure exactly what that means. So what VRF does is it returns a long random number, and you can choose how many of those you want back. You can choose to have just one of those or 10 or however many. Maybe when you see the demo, it'll make more sense. And if not, you can ask your question again. So once you have randomness on chain, this opens up a huge number of use cases, from things such as NFTs to games and DAOs, right? And with NFTs, VRF has actually been used extensively in the NFT ecosystem, from generating, NFTs with random traits to even enabling a fair and transparent minting process, where VRF is used as part of that minting process to basically randomly assign NFTs to specific people that are on a whitelist or something. So probably one of the biggest use cases of VRF as well is gaming. So gaming requires randomness. Blockchain games and GameFi, they're becoming bigger and bigger as, every month that goes by, right? And with VRF, these games can have true and verifiable randomness. What is meant by NFTs? another great question in the chat. I think we're going to go through that in a second, actually. So let's just hold off on that one. So here's just a couple of examples of how VRF is used in some dApps. We've got Avagotchi uses VRF, as well as Pull Together, which is a lottery dApp, I believe. So check, they're pretty popular, actually. I highly recommend checking those out. Let's do a demo of VRF, and hopefully it will make a bit more sense to everyone for those who are kind of a little bit unsure of, how it works still. So if we go back to docs.chain.link, we are going to go to the using randomness section. So once again, you're going to want to make sure that you've got some link tokens and some ETH in your Web3 wallet. And the first thing you need to do when using VRF is you need to create what's called a subscription, right? So the subscription manager, which can be found here, the URL is, it's actually vrf.chain.link. Let's make that a bit bigger. As you can see, it's connected to my wallet here on the Go Early network. And we are going to create a new subscription, and it's automatically populated the address from our Web3 wallet, and we're going to hit the create subscription button here. Ravagotchi, hey? So you need to confirm the transaction. I may have said Ravagotchi, it's after midnight here. So we're going to give that a few seconds to complete. What are some beginner-friendly projects using VRF? Oh, that's an interesting one. A really cool one is the Big Mac raffle that we recently did for SmartCon. If you go to Andre J Dev on Twitter, I'll paste that actually here. He's linked somewhere in his Twitter his Big Mac raffle that he created for the SmartCon conference that we did. And that's a really cool example, simple example of using VRF. Cool. Okay, so the subscription has now been created. Let's add some funds to it. So you need to pre-fund your subscription with some link, just like how you'd pre-fund your travel pass or bus pass or Opal card or whatever it's called with money before you can then use it on public transport. So we're going to add 5 link in this case. It should be plenty. We're going to give that a minute to complete. Cool. So once that's done, we can now press the Add Consumers button. Cool. So as you can see, we have a new subscription here with a number. In this case, the number is 4613. So now we can create a smart contract to then use that. So I'm just going to close this one. So back in the Chainlink docs, we're going to go to the Get a Random Number link here. And we've created and funded the subscription. So we're going to scroll down and you can see there is an example smart contract here. So we're going to once again hit the Open in Remix button, and I'm going to open it in Remix. And we can see a bunch of code here. So I'm going to compile that. So basically, let's take a look at this code. So we're importing some Chainlink libraries here. We're creating a smart contract and saying it's using VRF consumer base v2 and this confirmed owner here. We're defining a couple of events. And the thing to note is here, we have this S requests mapping here of uints to request statuses here. This is basically where we're storing our random numbers, right? And another thing to note is we have a key hash here. So this is basically what gas lane you want to use. So when you're doing a request for randomness, you can actually specify different gas lanes to say, hey, this is a real urgent request. I'm willing to pay more link for this. So make it go through ASAP, or I want to be more careful with my money. It doesn't matter if it kind of goes through, in a normal time. So use this key hash instead. So we're going to go with the default one here, which is just normal, I think. There is some other variables here. So how many words is how many random numbers you want. I know the words thing is a little confusing, but in this case, we're going to go with 1. Request confirmations is how many confirmations you want to wait before we can consider the request to be valid. And then the callback gas limit is what is the gas limit on the callback transaction to send that random number back on chain. In this case, we're going to leave it as 100,000. So in terms of the other stuff that the code's doing, it basically boils down to 2 functions. So first of all, when the contract is deployed, we're passing in the subscription ID, which in this case is this 4613 that we created earlier, and that's getting stored. Some stuff is getting initialized. These values are specific to the environment that you're in. So in this case, it's defaulted to the go early values. But if you're running on Polygon or Avalanche, if you go to the supported networks section in the docs, you can see, BNB chain, you can see all the specific values here for each one. But in this case, we're running on go early, so we're going to leave things as is. Now let's take a look at our 2 functions. So we have a function for requesting randomness, and then we have a function to receive the random number result from the Oracle, right? And then there's just a get request status function. But in this case, the request one is the one that says, hey, I want to request a random number. It builds up a request here, it emits an event, and the Oracle, it goes through a coordinator contract that sits in the middle, and then an Oracle will receive that and then do the request. And then when the response comes back on chain, this fulfill random words function gets called. In this case, we basically just store the result in this S request mapping here. Array. And that's it. It's pretty simple. So I've compiled it. I'm now going to try deploy it. Let's make sure we're on MetaMask. And let's make sure we're deploying the right thing. So in this case, when we deploy, we have to specify the subscription ID. So this is 4613. So we're going to put in 4613. We're going to deploy. So from my understanding, VRF is a contract call. So I have to wait for it. Does this mean I can't use it in, say, a role-based game? Yes. So VRF request is not an instantly fulfilled thing like price feeds. The random number is not already on chain. So it actually takes place across 2 transactions. So depending on your network and gas limits and stuff and lanes that you choose, gas lanes, it can take anywhere between 30 seconds to 10 seconds to 2 minutes, depending on the network. Cool. So that's deployed. So let me just hide this question. If you look down in the bottom left, you see we have a VRF v2 consumer contract here. I'm going to copy the contract address here, and back in my subscription that I created, I'm going to now add that VRF smart contract as a consumer address here to say, hey, for this subscription, I'm going to be requesting randomness on this smart contract here. So basically allowing it access to basically take link from our subscription here. When is the session going to finish? After VRF, we're going to be about halfway through, I'd say. So maybe another hour. Hour at the most, maybe. So hopefully that finishes. And once that's done, we should be able to then do our request for randomness. Cool. Okay, so that's finished. We're going to hit the view subscription button. And as you can see, the UI shows us some information about our subscription. So here's our subscription number. Here's the balance. There's been no VRF requests fulfilled. We have one consumer that we added, and you can kind of see the history here. Cool. So now let's get some randomness on chain. So we're going to hit the request random words button here, which is going to call this function here, hopefully. So we're going to confirm that transaction, and we're going to wait just a few seconds, and hopefully we should see that request come in on the user interface here against our subscription. So if I go and refresh the page here now, do we have anything yet? No. If you're using Polygon or Avalanche, this is a lot quicker, especially Avalanche. Go early is definitely a little bit slower than those two. Oh, okay, the transaction just went through now. Let's take a look again. There you go. You can see we have a request pending here. So that should have gone through by now. Let's go back to our smart contract. And there's this actually, we can actually look at the last, where is the variable here? Last request ID. It actually will get the last random number request that was done. So here you can see the random number here. Let me see if I can bring it up here. Yep, so the very first request ID, which is 0 in this case, as you can see, there's a random number. So there's a random number. It's this really long number. You can then do whatever you want with it. You can basically use it as a source of randomness. You can create other random numbers from that random number. The possibilities are, it's entirely up to you. So there's just a basic example of creating a subscription using VRF, creating a simple smart contract that requests a random number, and then initiating the request, and then getting the random number back on chain. If you go to our docs, there's some more info here. If you don't want to do things through the UI, if you want to do everything on chain in the smart contract, there's a programmatic subscription link in the docs, and there is an example contract which programmatically creates the subscription, funds it, adds the consumer, and does everything that we just did on the UI, but it does it all in smart contract code as well. So if you want to not do the UI stuff, you can do everything programmatically as well. Cool. So that was VRF. Let's move on now. Great question in the chat. Is VRF only available on EVM chains, i.e. not on Solana? So if you go to the docs and go to supported networks, you'll see all the networks that are supported for VRF. So we have Ethereum mainnet, Ethereum Goerli testnet, Binance chain, Polygon, Avalanche, Phantom, and recently Clayton. So no, VRF is not available on Solana just yet, unfortunately. However, hopefully it is soon, because I'm a big fan of Solana and VRF. If you're a Solana person, we have price feeds on Solana, and I recommend you definitely have a play with those on Solana. They're awesome. And we have a prize track for the best Chainlink hackathon project on Solana that uses price feeds as well. What are EVM chains? So EVM chains is any blockchain that uses the Ethereum virtual machine, like Ethereum does. Okay. Let's move on to Chainlink automation, or as I like to call it, the Chainlink service formerly known as Keepers, because it was recently rebranded. Cool. So we've talked about Chainlink price feeds. We've talked about Chainlink VRF. So let's talk about Chainlink automation. So Chainlink automation is another service, a Web3 service, and it offers smart contract developers the ability to automate their smart contract function calls, right? And it does this using a decentralized network of what we call keeper nodes, but essentially you can consider them as oracles. And by doing this, they offer you a really high level of security and reliability in regards to your smart contract function calls. So essentially, if you have a function in your smart contract and you need to trigger it based on certain conditions automatically or time, let's say you have an insurance smart contract that checks the weather at certain locations once per day, how is that smart contract function getting triggered? Are you doing it manually? Is it done from a front end? Is it done from a process running on the cloud, etc.? They're not the most reliable ways. So what Keepers allows you to do is to basically create what's called an upkeep job to say, hey, I want you to call this smart contract function once a day at 3 o'clock p.m. every day for the next 90 days. And you fund that with Link, and then Chainlink Keepers will 100% always do that smart contract function call for you based on those conditions that you set. So it provides that off-chain automation for you in a decentralized and highly secure way. So you're not relying on a cloud service, you're not relying on someone doing it for you, you're not relying on a front end, you're not relying on a process running on someone's machine, right? You've got this decentralized network of nodes that's going to 100% do your function calls for you based on the conditions you set. So what are some use cases of Chainlink automation? So one really cool one that I like is dynamic NFTs. So basically an NFT is a online digital asset that's unique, it's non-divisible, and it's non-interchangeable. Most people know this, but if you're new, you may not. So the thing is, today we have NFTs like CryptoPunks and things like that, where they're basically static, right? But for the future, where we're seeing a lot of strong use cases where people are looking at NFTs that are not just static and they're actually dynamic, right? So like this basketball card here that updates over time based on player performance. So the fact that the NFT changes over time is like awesome. And it makes you think, what else can NFTs be if we can do this with them? So how does Chainlink automation enable dynamic NFTs? Essentially, pardon me. Essentially, when you need to do a call to update the NFT based on external data, you can automate that with Chainlink automation to say, hey, at the end of every week, once all the basketball rounds have been played, let's pull the data from the online APIs and then update all of the NFTs with the latest data. So another use case for automation is automating DeFi functions. So for example, Chainlink automation helps certain DeFi protocols such as Beefy Finance automate their yield harvesting and compounding strategies, right, offering greater reliability and transparency. So if you have a DeFi protocol that requires certain functions to be called or executed based on certain conditions, Chainlink automation offers you this functionality without having to sacrifice on security or reliability. Cool. So let's do a demo of Chainlink automation now. So Chainlink automation works in a similar way to Chainlink VRF, where you have a subscription that you have to create, and then you add a consumer to that that uses Chainlink automation, and then the consuming smart contract takes Link from the subscription for each request that you do. So we're going to shut these. We'll shut this one, we'll shut this one, this one. So if we go back to the docs here, if you scroll down, you'll see a automate contracts section here. So actually with Chainlink automation, you can actually the trigger for when you want your functions to execute can be based on time, or it can be based on custom logic, right? So you can create what's called a time-based upkeep to say, hey, I want this function to execute every day, every 20 seconds, every 30 seconds, every 2 years. Or you can have it based on custom logic to say, hey, when the price of Ethereum is this, or something like that, this is when I want my function to execute. But for now, we're going to create a subscription. So the first thing we want to do is to open the Chainlink automation UI. Once again, we're going to be connected to our Web3 wallet, and we're going to register a new upkeep. So in this case, we'll do custom logic for this demo instead of time-based. And it's asking for our target contract address. So we haven't deployed one yet. So let's go back to our code, to our docs here. So in the example contracts link, I think, no, it's not there. Let's have a look at creating compatible contracts. Yes, let's do this one. So in create compatible contracts, we see an example smart contract that we're going to open in Remix. Let me make that a little bit bigger for everyone. What programming languages do we need to know to do this? So I'm just using Solidity smart contracts, and that's all you kind of need to know. Could automation be used to trigger execution of a swap in the future? Yes, if you have a custom logic that says the time needs to be this time in Unix time for it to execute, or greater, that's a perfect condition for it to trigger. So that's a custom-based logic trigger, not a time-based one, because I think the time-based ones are based on a they're based on the, what's it called, the Unix format. Where is it? Cron. Yeah, it's a cron expression for time. Okay, so let's take a look at the contract before we deploy it. So let me expand this a bit. So it's using the a library here. We're creating what's called a counter contract. So this is a very simple smart contract that simply has a counter, and we're using Chainlink automation to automatically up that counter by 1 each time, right? So here's our counter. It's just a simple uint. And in the constructor, we're saying how often should the counter update. So we'll probably set it to 30 seconds or something. So we're storing the last timestamp. We're storing the time and date in Unix time when the smart contract is deployed, and we're setting the initial counter value to 0. So these are the two special functions that custom logic-based automation uses. So check upkeep is the function that the automation Oracle network runs to check if it needs to do the work. So every single round or every single block it will check. In this case, we're basically just doing a check to say, hey, if the current block timestamp minus the last time we did the counter increase is greater than the interval, which might be 30 seconds, then return true, which is like, yes, you need to do the update. And then if that returns a true, the automation network will then call this perform upkeep function, which is simply going to increment the counter by 1, right? So very simple, a function to check if it needs to do the update, which basically says, hey, has it been 30 seconds since the last update? And then a function to do the work if that returns true, to then update the counter and increase it by 1. There's a great question in the chat. Will we have a tutorial on Solidity? Yes, there is a, when is it? Let's take a look. You go to hack.chain.link. go to the schedule on here. So at 1 o'clock ET today, intro to Remix and Solidity. Sol's going to be running that one, and I highly recommend you checking that out if you want a great intro to using Remix, which is what we're using here, and to writing your first Solidity smart contracts. So definitely check that one out. So let's compile this smart contract and let's deploy it to Go Early. So I'm going to make sure you've got that one deployed. So we're going to say the interval is going to be 30 seconds. So we want to update the counter every 30 seconds. So we're going to confirm that transaction. And once that's deployed, we should see it down here in the deployed contracts section. Cool, so we can see it down here now. I'm going to copy the contract address and I'm going to put it in the target contract address here. Did I get the right one? Let's see. Next. So we're going to give our upkeep a name, Harry Pest. So gas limit is the amount of gas to provide the target contract when performing the upkeep. So this is basically saying how much gas should be used at the most when doing the actual upkeep, if it deems that it needs to do the work. So we'll leave it set to 500,000. We're going to fund the starting balance as 5 link for the smart contract. You can pass in input parameters to the function here, but in our case, we don't need anything. We don't need to pass anything in, sorry. So we're going to leave it as blank, and we don't need to put in an email address or project name. If you're looking to get a team mates, you don't need to attend both team formation events, I believe. If you attend the first one and get teammates, awesome. If not, you can definitely attend the second one as well. So I'm going to approve my transaction here. And now we're just going to wait a few seconds for that to complete. Cool. That's finished. So now we're going to press the View Upkeep button. This is where we can see all the information about our upkeep that we created. So here's the status. Here's the history where we funded it with 5 link, and there's nothing else that's kind of happened yet. But if we wait a bit and refresh, hopefully we'll see something happen, because now that we've done this, so the counter is still set at 0. So the smart contract, nothing has been done to it, but the keeper network should now start checking the smart contract to see, has 30 seconds passed since, in this case, when the smart contract was deployed. And if so, it should then call this perform upkeep function, which should increment the counter by 1. So let's go back to the upkeep details here and let's refresh. And nothing has happened yet, so we'll just wait a few more seconds. This is the same as VRF. If you're using Ethereum, it's a little bit slower than if you use, say, Polygon or especially Avalanche. Avalanche is very fast. Let's check out this question in the chat. So can I use more than one contract with the same upkeep? Yes, you can add multiple. You should be able to. Let me see. I thought you could, but it looks like you can't, actually. Let me just see here. Yeah. So for each contract, it looks like you need to create a new upkeep and fund it. It looks like Go Early's doesn't want. Oh, there we go. I was about to say Go Early is being very slow, but it looks like it's done something. So let's take a look. Cool. So as you can see here, perform upkeep was called on our smart contract. Some link was deducted from our subscription. If you go to our smart contract, counter has been incremented by 1, and the last timestamp has been updated. So there you go. The Keeper network has determined that 30 seconds had passed, and it had ran our perform upkeep function, which incremented the counter. And if we wait a little bit longer, it's probably going to do the same again and again. Because we didn't specify any bounds in which to stop it, it will probably just keep going until the link balance is exhausted. So that's an example, a simple example of using Chainlink automation in your smart contracts. In this case, we did a custom logic-based one where we have a check upkeep function. However, you can easily recreate this. Do we have time to do it? Maybe we'll get to it at the end. If you do this as a time-based one, if we go back to here, if you do it as a time-based one, I wonder if I can do the same one. Let's see. See, you can say what is the target function to call. In this case, it's perform upkeep. What is the input data? There's no input data. And here's where you do your cron expression to say how often you want it to execute. So that's every 15 minutes, every 1 minute, and we'll kind of tell you the next 5 scheduled dates here. So I won't go through this part because it's exactly the same now, but there you can kind of see an example of doing a time-based one where you just specify the schedule as a cron schedule, and it will automatically do it based on that schedule and what function you tell it to run. Great question in the chat. Is it possible for an off-chain event to trigger Chainlink automation? Yes, you can. So once the upkeep is registered, it'll start executing by itself, and it will check all the time, every block, right? However, you can initiate that process from off-chain. So like I said earlier, let me just find the example. Yeah, it's here. So once it starts, it's going to check every time. However, you can initiate that process off chain by programmatically creating a subscription and funding it, just like how I showed you with VRF before. However, generally, most people would just basically define the upkeep, define the conditions, and then once that's created through the UI, just kind of let it run on its own after that. I hope that answer helps a bit. Cool. So that is automation. So, oh, I see one more question in the chat. Hold on. Where did you specify the frequency of the update on the Chainlink side? So In the example that we did here, we didn't, because we created a custom logic-based trigger. That's where you have to have this check upkeep function, right? And in there we define the frequency by basically saying compare the current blockchain timestamp to the last time it was stored, and then if it's greater than the interval, which we defined as 30 seconds, then return true here. So it's basically a long-winded way of saying, has it been 30 seconds since the last update happened? If yes, then call perform upkeep. So this is, it uses the custom logic trigger, but it's essentially a time-based one, right? We're just kind of doing it manually. Awesome. Hope everyone got a good grasp of what Chainlink automation is. So now we're going to talk about the last service that we are going to showcase today, and that is the OG Chainlink use case, API calls. So this is the original functionality of an Oracle and the Oracle network like Chainlink, the ability for a smart contract to reach out and make an API call, right? And this obviously opens up a huge number of use cases, because with API calls and Chainlink nodes, you essentially get all the connectivity and flexibility that a Web2 app has today. So we actually see lots of projects in hackathons and hacker houses use this API call functionality, because you literally can connect a smart contract to anything, right? You can connect it to a backend system, to a database, an IoT device, anything that has an API, right? And the way in which Chainlink API calls work is it uses what's called the request response model. So a smart contract does a request to an API to say, hey, I want to reach out to this REST API, which is going to return, some kind of data, sports data, whatever. And then that request is then picked up by a Chainlink node. And that Chainlink node then processes it does the request, it does the API call, it gets a response, and then it sends the response back to the smart contract on chain. And the smart contract then receives it, and then it has the answer, and it can do whatever it wants. So that's kind of how it works at a high level. In terms of the Oracle itself, you kind of, it's not like Keepers or VRF. You kind of have to specify what Oracle you want to use. So some people run their own node, and then there's going to be a session later in the hackathon on running your own node. Or if you're just doing a simple API call that's doing a HTTP GET and you want a string or a byte or a uint, I recommend going to our docs here, and in Connect to Any API, there's a testnet Oracle section where you can get some Oracle job IDs and operator contracts here. And if you're not sure what those are, we'll go through them in a minute. Another option for doing API calls and running your own node is to use Linkpool's Node as a Service. I'll post a link in the chat to check out. This is where you can use Linkpool's Node as a Service to run your own Chainlink node, so that you can do your own API calls. But for this demo, we're just going to use the testnet oracles here, which are ones that the Chainlink Labs team run on the testnet. I see a couple of questions in the chat. We'll get to them at the end. So let's take a look at how an API call demo works. So if you go back to, we're going to shut this. We'll shut that one and that one. So if you go back to our docs at docs.chain.link, if you scroll down to the Connect to Any API section, then in Make a GET request, you will see an example smart contract here in the single word response section. So Chainlink API calls, you can get back multiple values now, but for this demo, we're just going to do an API call to get a single response back. So we're going to open up this example smart contract once again in Remix. And I'll compile it, and then we'll run through and see what's going on. So we have a smart contract called API Consumer. It uses some Chainlink libraries here. It's got a volume variable, a job ID, a fee, So in the constructor, where we're setting the Chainlink token. So in this case, we're setting it to the Go Early link token contract. We're setting the Chainlink oracle to the Go Early oracle contract address here. Let me just get rid of some spam in the chat. Sorry about that. Let's go back to this. The job ID, in this case, I got from this testnet oracles page 2. In this case, it's the job ID to get a uint 256 value. Right, so this is basically saying, hey, we want to use the Chainlink DevRel node to do this API call on Go Early. So that's this address here. And our request is to get a uint 256 from a HTTP GET API. So we're going to use this job ID here. And in this case, we're setting a fee. So you have to pay a fee for doing an API call because the Oracle node has to pay gas to send the response back to you. And they take a fee. In this case, we're setting it to 0.1 link, I think. Yeah. So then we, like VRF and automation, the main part of the smart contract is essentially split into two. There's a request function, and then there's like in this case, the fulfill function, which ends up getting called when the response comes back on chain. So in the request function, we're essentially just building up a request here, and we're adding some stuff to it, and then we're sending it off to it ends up getting to the node. So this here is the URL of our API. So in this case, it's a public open API that simply just returns Ethereum price data. So as you can see, it returns a whole bunch of stuff. So in our case, we are interested in by specifying the path parameter, we're interested in the raw ETH USD volume 24-hour value, which is this one here. So that's what we're trying to grab from this API here. We're multiplying the value by 10 to the 18 to get rid of the decimals. And then we're sending the Chainlink request. We're saying, hey, we want to reach out to this API. We want to grab this value here. Then I want you to multiply it by 10 to the 18 to pad it out with zeros and then send the response out. So that's what that function is doing. The specific oracle that we're using here and the job that's running on that oracle will get that request. It will do the API call for us. It will grab the volume here. It will pad it out with zeros, and then it will send the response back, and it will make its way back here in this function call, and we're just going to store it on chain. So there's that request response kind of format here. Now that that's compiled, let's go and deploy it to Go Early. So we're going to go deploy. Now, the thing with API calls is there's no subscription service or something in this version of API calls or any API. So you have to manually fund the smart contract yourself. So in this case, we'll wait for the deployed contract to come. So there's our deployed contract. I'm going to copy the address and I'm going to manually send it some link here. So we're going to go link, send. Oops, I funded it with 1, but I think the request is only 0.1. Doesn't matter. So in this case, I'm sending it 1 link. We only need to do 0.1 to do 1 request, but that's okay. I don't have the slides available for immediate download, Hen, but what I'll do is I'll update the YouTube description after this finishes within an hour, and I'll share a link to the slides that you can download. So thanks for asking. So this contract should now be funded with some link. So I'm going to call the request volume data function, which is going to call this. So it's going to build up our Chainlink request by saying connect to this API, grab the volume 24-hour from it, multiply it by 10 to the 18, and basically send us a response back to this fulfill function here. and we should get the value coming back, and we should store it in the volume variable here. Is there a way to create your own decentralized Chainlink data feed service? Right now, it's not something that we officially support. However, some people have reverse engineered the smart contracts and managed to do it. But you can do it manually using the API calls here. So you can manually create a smart contract that does multiple API calls to different nodes, different data points, and then manually aggregate stuff on chain yourself. Cool. So we've waited a few seconds for that. Let's take a look at the volume. So as you can see, we have the volume here. It's 462975, etc., etc. If I go back and refresh here, you should be able to see it be similar to that. Obviously, it's been padded out here. So there you go. We deployed a smart contract that built up a request to an API to get some volume data from this crypto compare site. The Oracle received the request. The Oracle that's running the Chainlink team is running on Goerli, and it received the request. It sent the response back, and then we store the response back in this volume. So very simple smart contract to show you how you can do API calls using Chainlink. If you're doing something that's not a simple HTTP GET request, you may need to use what's called an external adapter, and there's a workshop on that this week. So I recommend checking that out. So if you need to do anything really custom or really different, that's not just a simple HTTP GET or POST request, definitely check out that session there. And if you're not going to use the testnet oracles we have here, I'll paste this link in the chat, and you want to run your own node, do your own API calls, definitely check out the running a Chainlink node session later in the week coming as well. So that is any API. Let's see if there's any other questions in the chat. In this case, when I want data from the off-chain world and put them on Chainlink Oracle's network so I can use the data on-chain, yes, this is exactly what you would use any API for. If you have data in the off-chain world, in a database, in a system, in an API, anywhere, and you want to have that data in your smart contract, you would use this any API functionality to connect to that off-chain system that has the data and to grab the data and then to store it or use it in your smart contract application. Another great question in the chat. What about API keys? Yeah, this is an interesting one. You don't want to store API keys on chain because then everyone can see it. What people generally do is they usually run a node, and then the node has the API keys defined in an ENV file or somewhere, and the node uses the API key. You can get it from an environment variable, etc. Or what some people do is they create external adapters that the node uses, which basically stores the API key in like a .env file or something. So definitely recommend checking out the running a Chainlink node session and the running an external adapter session for more info on this, because they'll probably go through a use case exactly like that. Great question. So let's wrap things up. So today we learned about what the limitations of blockchains are, what is an oracle, what is Chainlink, how do Chainlink Web3 services enhance blockchains. We talked about using data feeds to get high quality price data in your DeFi application. We talked about using VRF to get randomness in your game or your NFT drop or whatever thing you're building that needs randomness. We talked about how you can use Chainlink automation to automate function calls in your smart contract in a highly secure and decentralized manner. And we just went through how you can do API calls from your smart contract and connect your smart contract to external data and events. I'll get to the last questions at the end. Thanks. We've pretty much finished. So where to go from here? any questions you have, ask in the Chainlink Discord in the hackathon section. Myself and the other developer advocates are going to be monitoring that throughout the hackathon, and we'll help you out there. Everything I went through today is in the Chainlink docs at docs.chain.link. So if you want to play around and redo everything that I've done, or just explore some of these Chainlink services more, definitely check out the docs as well. And if you want just some general educational content on Chainlink, you can go to chainlink.education, and our GitHub repository at github.com/smartcontractkit has, apart from our node software, it actually has what we call starter kits, which are boilerplate repositories for using Chainlink in your applications. So if you like building projects using Hardhat, there's a Solana one too, and I think there is a Brownie one too, and a Foundry one. So whatever development framework you use for building Web3 applications, we've got you covered. So definitely recommend checking those out as well. But yeah, other than that, I hope everyone found some value today and learned a bit about what Chainlink is and how it can really supercharge your smart contract applications. And really excited to see what everyone builds. So definitely reach out to us if you have any questions in the Discord, and we look forward to interacting with everyone throughout the hackathon. Let's take a look at this last question here. Is there a place where we can view the submissions of Chainlink hackathons for previous years? Yes, you definitely should be able to. Let me see if I can find that for you. So all of them are in dev post usually. So here is the very first hackathon in 2020 that we ran. Here is one that we ran in 2021. Here is the one that we ran earlier this year in spring. So all I'm doing is I'm Googling dev post, Chainlink, and then the year. And we do one in fall, we do one in spring. So you should be able to find them all there. You can see all the winners, all the project submissions if you want some inspiration. Any other questions in the chat? Feel free to ask now. Yeah, no, great question to ask. If you're a beginner, definitely check out some of the previous hackathon submissions, and you'll definitely get some inspiration there. Awesome. I think we're at the end now. Once again, thank you for joining. Looking forward to interacting with everyone throughout the hackathon. We have more workshops coming up later today, I believe. So definitely check those out if you find them interesting. And yeah, looking forward to seeing what everyone builds. Thank you. And I hope everyone has a great rest of the day or rest of the night. Thank you.